Hi, this is Jerry, Kilo Mike 4, Zulu Kilo Bravo. Today we're going to get into part 2 of our build of the remote antenna switch. We're going to build and test the relay board. We're going to go through how the relays work. You're going to want to watch this to the end. It's going to be an interesting video, and I think you'll learn a lot. This is going to help you to understand how the antenna switch works and how you can build one for yourself. Watch to the end, and before we get into it, take the time to give a thumbs up, give a like, share this video with your friends, and if you haven't already, please subscribe. Leave a comment. Everything that you do helps the YouTube algorithm to push this out to more and more people. Let's get into it. Well, after much calculating and estimating and trying to figure out where to lay out these different components, this is what I've come up with. I'm going to have to drill and cut a lot of holes. I've got the mounting holes marked for the relays here. I've got the holes marked for the barrier strips here and here. And there's no particular reason why these are larger than these. I just bought them from two different places, and that's what they had. I'm going to mount the SO239s here, but this will be bent at 90 degrees up like this so that the connectors will be facing down. And I've got to drill the holes for those. There will be a bolt here to connect to earth ground. I've got a ground rod driven into the ground out near where this control box will be mounted, and I'll have earth ground here, so that will ground all the shields because the SO239 will be riveted to the plate here, so there'll be a common ground. The electrical ground will be separate, and I'll show you the wiring. I'll wire one setup so you can see how the wiring is done, and then I'll walk you through that so you can see how it will work. And then once we go through that, I'll go ahead and connect the rest of them because they will just be copies of what the first one is done. So when we get through, it's gonna look pretty complex. The wires are going to look like spaghetti factory, as I said. But this is a prototype. So I need to get busy and drill a lot of holes. We'll get back once I'm through with that and have all this mounted. Once it's mounted, this is bent up. After the holes are drilled, then we'll go over it again. Bear with me as I go make a lot of holes in this metal plate, and I'll show it to you once we get through with making the holes before I mount it. Well, we've got a lot of holes. There's lots of things to mount, and I think I've got them all drilled. I'm going to have to bend this up like this, and then the actual SO239 will end up facing down like so. And we've got the relays to be mounted across here, two of the barrier strips here, and the other two barrier strips down here, terminal strips, whatever you want to call them. Different people call them different things. I've gone ahead and mounted the Cat 5 connector here. I will be punching down the wires and then running the wire through here, which will then connect to one of the terminal strips here. When we come back, you'll see all of the hardware mounted, and then we'll start wiring the hardware. I did run out and buy some hardware this morning, different stainless steel screws, washers, and nuts in order to mount the hardware onto this aluminum sheet. We'll get that going and come back and then show you how to wire up the first one, and then we'll do the other 5 the same way. So hang with us. Okay, we've had a lot change since last time you saw this. Kind of got carried away a little bit. We've got some things mounted both in the relay panel and in the control box. Wanted to show you I have downsized my power adapter. The other one was putting out too much voltage, and I thought there was going to be more voltage drop. I've got 200 feet of Cat 5 cable here, a little over 200 feet in fact, and I thought the voltage drop was going to be significant, but it is not. We'll measure that here in a minute. This one here is rated at a 12 volt DC output at 1 amp, 1000 milliamps, but when it's floating, when it doesn't have a load, it's really putting out close to 18 volts. So we're gonna measure it. I've got it connected here on the control box, and the other thing too that I wanted to point out, you could use your shack power, because this is 12 volt. This is a 12 volt system, so you don't have to have a wall wart if you don't want to. And you may or may not want to connect this directly to your shack power. There's some advantages and disadvantages. One thing, it's clean power. You don't have to worry about any AC hum or anything like that being induced into your antenna system. And depending on what wall wart you have, I haven't checked this one specifically yet. I haven't connected this to a radio. This one may not be any good. This one may have too much noise in it. I don't know. But we're going to find out. Okay. Right now I'm just in the prototype. I'm testing, and we'll get into that when the time comes. It's not going to change the design of the switch. You just may have to change to a different power supply. And who doesn't have at least a half a dozen wall warts of different voltages and configurations? You know, you cut the plug off of it, you don't have to worry about polarity. You just connect your positive to your positive and negative to your negative here and be done with it. That's what I've done so far. The reason I changed was the relay was actually getting warm. Even though going through all this wire, it was getting warm, so it was getting too much voltage. Again, we will test this in just a minute. But what I've done here, I've added a connector to connect the rotary switch. You can see here I've added these wires here. That's a little nasty connection there. I need to clean that up. Sometimes I get in a hurry, but it's working, but the connection just looks bad. Okay, I've got the 12 volt for the relay control here, and I've got the 5 different wires here that can send out the signal to the 5 different relays on the relay panel. And what I've used here, you know, on the underside of this prototype board, I've got this this female socket soldered in, and then I've got these Cat 5 wires soldered in, and they're connected on the bottom side. If you've done any prototyping at all, it's a common practice. Okay. Then I've got the negative here connected to the negative bus over here, and of course the positive connected over here to the positive bus. And then I've got the first 5 wires are connected through this Cat 5 cable over here, and you see I've got the Cat 5 receptacle both on the control box and on the relay panel. And I can show you on the back of the relay panel here pretty easy. Get the protective cover off of it here. Thought it'd come off easier than that. There it is. You see the different wires are just punched down according to the chart that's inside the Cat 5 connector. Okay, as long as you do it the same on both ends, okay, as long as they're punched down the same on both ends, it doesn't really matter. You don't have to follow their layout as long as it's the same on both ends. Okay, you can see all the bolts here. I've also got the SO239s connected, or mounted, I should say. And I chose to rivet them in. It was just cheaper. I had pop rivets and I had the rivet gun already, but you can use screws and nuts and washers, not a problem. Let's go over a little bit here what we've got. All right, I've just wired in one relay, so it'd be easier to follow, and it doesn't look so much like a bunch of spaghettis all together. And I want to stress a couple of things here. This group of relays, I don't know if these colors are industry standard or whether they're just unique to this relay. What you need to be aware of is the function of each of the wires. According to what they say here, I've kind of got the contacts backwards because I've got two different inputs that I want to go to a single output. And the relay, of course, has two positions. It's got a normally open and a normally closed. Normally open is where you would put your lead to your coax, your feeder coax, because it will not connect to the relay until you energize the relay. And that's how you select which antenna. When you energize the relay, the normally open closes and the normally closed opens. And then when you turn the knob to select a different antenna, opposite happens. You know, it closes to the normally closed position because it's spring loaded, and it opens the normally open position. So you're going back and forth between normally closed to normally open, back and forth. That's what you're doing, is you're moving that lever in there, or the moving contact back and forth by energizing or de-energizing the electromagnet, which is what it is. All it is a switch that's controlled by an electromagnet. And an electromagnet moves that contact between the normally closed position to the normally open position. And I will have a diagram for you that'll be generic. You know, this one is based, this is just how the relay is wired itself. Has nothing to do with how it's implemented, other than you've got to realize what your different wires are doing. But your colors may be different, so don't assume that the colors would function like these do. In fact, it may not even be the same color. I don't know, like I say, if these are industry standard or not. So check to make sure the function of each of the wires, and I'll draw up a diagram, and that'll be downloadable for you to see how this works. Now let's go over this a little bit. What we've got here, This antenna connector here, make sure, yeah, you can see that. I'll push it up a little bit there. But this antenna connector here, all the way to the left, this is the one that goes to your shack, okay? This is the one coming from your radio going into the relay panel. And like I said, I've only got one wired in so we can see it and go over it a little easier than having all 5 of them wired in. And in conjunction with this, I've got a gas discharge tube. And what that does, this gas discharge tube is rated at 1500 volts. And if it gets, you know, an impulse from a lightning strike, of course, if you get a direct lightning strike, you're out of luck anyway. But if you get a smaller surge than a direct strike, this will route it to ground. This particular screw right here goes through to the metal, and this metal will be grounded. This is going to be our ground, the equivalent of a chassis ground right here. And all of these are connected together, going to chassis ground. And this chassis ground is going to go to a ground rod that's out near the antennas, okay, where the box will eventually be mounted. So all these are going to be common. This is the ground, and you can see here that we have one wire, this red wire, that's on the pin 87A, and 87A is the normally closed position. So without any power coming in here, if we were to check, let's get the ohm meter. And put it on where it'll beep when we've got connectivity. If I go to the center conductor here on this relay, and if I touch here, we've got continuity. So this is in the normally closed position. Now, what does that do? That means that any antenna that's connected here, if the relays are not energized, that's going straight through that relay to ground. Okay? If we go over here, well, there's nothing connected here, so I can't prove that point right now. But right now, that center conductor on antenna 1 is going to ground because the relay is not energized. It's in the normally closed position. Now, let's plug it into the wall here. And you can see we've got our light now. And it's in position 5. Let's go over to position 2. You know, there's nothing connected on 2 through 5 here, but let's just, you know, where we had okay, the relay is still not energized because it's in position 2. Let's put it in position 1. Okay, now we're not connected to ground anymore, but we're connected here. Now this bus bar here is going to be common to the feeder center conductor. Okay, so we've got the center conductor coming in here, and it's connected to all these on this bus bar here. This is where we'll connect all of our relays right here. So this is going to be common for our center conductor, and this is common ground here. And you also notice that we've got another gas discharge tube here. Both of these are rated at 1500 volts. And that's connected to the center conductor here. And that way we protect everything. And these are open. Right now we should get no connectivity across that. Same thing here, no connectivity here. Because the gas discharge tube, it's basically, it's an enclosed system, but you got two contacts in there that it takes at least 1500 volts to jump between one contact to the other. And that's how it gets any type of a surge over 1500 volts is going to route it straight to ground, which is this here. We've already got, you know, our shield from all the coax going to ground, and this again, this will be connected to the earth ground. So that's how this works. Now, what I've got up here, see, make sure you can see. Here's where all the different voltages from the control box come into the relay panel. Let's go to DC here, and over here is our common ground. This is ground for all the different connections, and and the black is the ground for the electromagnet in the relay. So if we go from here to here, we've got 15 volts. Yesterday when I measured it was 14. It's coming down a little bit there now, but it's 14.9 volts, which is maybe a half a volt higher than what you'd have in a vehicle when the alternator is charging. Normally a charging alternator is going to put out somewhere around 14.2 volts. So this is just about a half a volt higher. If we need to, and you know, you can feel just barely warm on this relay. It's been energized now for what, 5 minutes? But again, over here we've got another gas discharge tube, but over here we're using a much lower gas discharge tube, and I believe these are rated at 90 volts. Since this is a low voltage circuit and, you know, a small gauge wire, we need to protect it as best we can. And again, that's going to chassis ground from this Cat 5 cable, which is, this is position 1 on the switch. So if I take this and go to here, I'm not going to see any voltage. And I debated on this whether to use the chassis here as a common ground. My concern was, will I be introducing, you know, if the power supply is not clean power, if it has any distortion on it, AC hum, for lack, you know, is a term I'm used to using. If it's got AC hum on it, it could induce it into the RF circuit. And so I kept the voltage ground separate from chassis ground. But right here, like I say, we've got around 15 volts, and that's varying a little bit. Don't know why that's varying, but it is. But around 15 volts. That's not a, you know, that's just a wall wart. It's not well regulated. So it's around 15 volts right now. So we got 15 volts between these two. This is common ground. This is position 1 coming into this relay. So we've got this relay energized. Let's check our continuity again. We're going to put, it doesn't matter which one, we're going to put one into, this is the feed, and put it in position 1. And we've got continuity between the feed, the line that would normally go to your shack, and antenna 1 and change it to antenna 2, and it disconnects it from antenna 1. When we're in position 1, we're not going to see any continuity between relay 1 and ground. But if we switch to position 2, we do, because now this antenna is being routed through the relay to ground right here. All right, that's how this is wired. What I'm going to do is I'm going to duplicate what I've done here for these other 4 relays. And after I get through wiring that, I will show you again what it looks like when it's completely wired, and then you'll understand why I showed you with just one wired. So stick with us and you'll see the completely wired chassis. Well, hopefully the audio in that last segment wasn't too bad. I had clipped the microphone onto my cap and took my cap off. Hopefully in post-processing I was able to bring it up to a satisfactory level. I'm sure it doesn't sound as clear as this does, but I apologize for that. Well, here it is. I took a while to get here just because there are so many connections. It's really just lather, rinse, repeat. You know, get the first one wired right, get it tested out, and then just duplicate it 4 more times. But it takes some time. And right now I've got it turned off because I want to show that let's get the ohm meter going here in audio signal, and I've got the common into the center conductor of the feeder coax, and I'm going to test each one of the other centers, and of course there's nothing there, as there should not be anything there. Okay, so now let's check to see what the position is on all of the relays right now. On antenna 1, we'll check it, and it's shorted to ground because it's on a normally closed contact because power's off. Antenna 2 is the same way. Antenna 3 is the same way. Antenna 4, antenna 5. Now you can also see that they're connected to each other because they're all in the normally closed position. And normally closed shorts them to ground. All right. Now, let's go into number 1 here and turn the power on. And I heard this relay click. Now, it's not connected to ground, but number 2 is, number 3, number 4, and number 5 are all connected to ground. But number 1 is connected over here to the feeder coax. Go back to there and here. And if I turn it to number 2, this one should go to ground, which it does. Number 2 is open. Number 3 is ground. Number 4 is ground. Number 5 is ground. So let's check number 2. As soon as you turn it to number 3, it sends number 2 to ground. And number 3 is connected over here now. All right. So now let's go to position 4, which sends number 3 to ground, and number 4 isn't going to ground now. Number 4 is connected to the feeder. So if we go to number 5, disconnects number 4, sends it to ground. If we go to number 5, it's no longer on ground, and it's not to any of the others except should be to the feeder. And there we go. So we now have all 5 relays wired. We've got, that gets on my nerves real quick. Oh, probably does yours too. Everything is wired. And again, this is a prototype. I may or may not build another one, but I learned a lot building this one. Could it be done better? Oh yeah, it could be done a lot better. You know, I arbitrarily chose the size of this backer plate here, this metal backer plate. I cut that before I did anything else. You know, it could stand to maybe be a little wider. I think the length, you know, for this particular arrangement of components, the length is about right for me, you know, for these components. Using the terminal strips is not necessarily the best way to wire this, but it works. You know, ideally, all this could be put on a printed circuit board. And whether or not I do that may depend on what kind of reaction I get from this project. If there's enough interest, I could design a circuit board and have it made and sell those for a reasonable price. Tell me what you think about these, you know, whether or not this is something you're interested in. You know, I'm not asking a critique of my work. I know it can be done better. But for a prototype that's functioning, as far as I can tell, I'm pretty happy with it. Now, we have not tested it switching antennas yet, but everything points to that it's going to work. We'll find out in another part of this. I've got to build some kind of enclosure for this, because this is going outside. You know, it's going to be out near the antenna. I need to protect it from the majority of the weather, and from critters and everything else. So I got to build some kind of enclosure for this. I've got the holes to mount it to a frame to support it. I've got some poles out in the ground that used to have satellite dishes on them. I'm not on satellite anymore, but I intend to mount it to one of those poles once I get it built, because that's also where the conduit comes out of the ground. That's the reason I put my antennas there, because you know they had conduit under the ground for the coax for the satellite dish. Well, I used that to pull my coax through. I pulled out the old satellite cable and pulled in my LM400 coax, you know, low loss coax, and I had something like this in mind where, you know, I could get good benefit out of that coax and take advantage of that coax rather than buying multiple runs, because it's where my shack is in the house to where the antenna is, where it goes underneath the house and goes in the conduit out to where the satellite dishes were. It's about 175 feet. So that's the other reason I wanted to build something like this. And I want to give a shout out to Jeff, who suggested this project. He's a viewer and become a friend up in Bowling Green, Kentucky, with about 25 miles north of where I live. And he suggested this, and I don't know whether I would have built this without his encouragement and suggestion. So I appreciate that. Thank you very much. Hopefully this is beneficial to everyone out there. I'm sure, like I said many times, you can build it better than I can. You know, I kind of say, hey, if I can do it, anybody with a decent set of skills can do it. Let me turn this thing off. I think it's been beeping and I've been ignoring it. I'm an old Air Force trained electronics guy. I was a tech controller, 30750, while I was in the service. I didn't use a lot of my electronics training there, except in communications, because that's a communications position. But it's reawakened my desire to build things. In fact, some of the parts I've got are from kits and things that I've purchased along the way and had parts left over and such. You know, I'm happy with it so far. Hopefully this thing will check out like it should. I think it will. In the next video, I'm gonna have this mounted and connect 2 or 3 antennas. I only have one antenna out in that area right now, but I've got several portable antennas, so I'm going to set up 2 or 3 of my portable antennas and connect them, and then temporarily run the Cat 5 cable into the shack before I pull it through all that conduit, because that is a chore. But be able to control this from inside the shack and switch and take some measurements before and after to see if this introduces any SWR, additional SWR, or any other problems. And you see, I keep fiddling with the wires. I look at it, and that's my old electronics training. The wires that could possibly interfere with each other, I try to cross them at 90-degree angles so as not to induce any voltages from one to the other. Trying to keep them as separate as I can in this arrangement. I think this arrangement could be better, but it would take a lot more real estate. It would need to be a lot bigger in diameter, and you could probably put these in a circle and put these in a different location. There's lots of variations. And if you've got some ideas on how it could be done better, you know, I'm open. You know, send me a drawing. You know, my email's on QRZ. And, you know, if you've got drawings, you've got suggestions, hey, I'm open to looking at suggestions on how to do it better. Like I said, this is a prototype. I've never said I'm a fabricator or a builder or a maker or whatever you want to call them nowadays. What I have said, I'm more for functionality, and I'm not that much for details. And it seems to be working. We'll know more in the next video. But thanks for watching. I appreciate you watching, and it really helps the channel if you give the video a like, if you leave a comment, and if you subscribe. It helps the YouTube algorithm to get these videos out to more people. This hobby has given me a lot of pleasure, not only from getting to talk with people all over the world, but just the technical aspect of it. I've always been a techie from high school on up. Well, before high school, I was a techie. I dabbled in electronics. I'm a mechanic. I'm a welder, a network administrator, computer nerd. I've dabbled in a lot of different areas, but appreciate your comments, appreciate your support, and if you can, throw a little support my way. Use the Buy Me a Coffee link in the description from your phone or from your computer. It really helps. This is Jerry, Kilo Mike 4, Zulu Kilo Bravo. Hope you have a blessed day.